Good evening, everyone. Happy Diwali wishes to all of you. And we are going to start the new video today. Just a moment. Let me try it out. Okay, now it has worked. Okay, so we are fine. So this is about misconceptions in physics. Once again, welcome. So my name is Dr. Ratankar Rao. I teach physics in an international school, and teaching is my passion. And apart from it, while I grade the papers, I observe that some students make mistakes, and I just document these mistakes and find out what could be the reason for these kinds of mistakes. And then I find that when I ask these students what did they make the mistake, then I get to know that they make this mistake because they observe that there are two concepts which are very similar, and they get confused with one concept to the other, and as a result of it, they made a mistake. And towards it, today's topic of interest is center of mass, and velocity of center of mass is a vector, is the topic. Okay. The center of mass is always a confusing unit. Many people make lots of mistakes. How much ever time you teach, especially this comes in the chapter of rotation for JE mains and advanced. And most of the time I observe lots of mistakes creep up from this particular topic. Now let us understand what do you mean by this statement. Okay, velocity of the center of mass is a vector. The moment I say it's a velocity, this should be a vector only. Though it could be a point, but still, okay, it is a vector. Now let us understand, okay, what concept you need to learn from here, and how do you proceed with it. By the way, this is my 98th video I feel really happy because, okay, so I initially thought when I started this channel, maybe 10-15 videos I'll make, but later on, as time proceeded, I do not know, I got so many questions, overwhelming responses from all my students. Okay, in fact, I apart from my regular school teaching, I also take up tuitions. Okay, do one-on-one coaching. Okay, and so as a result of it, so I get so many questions. And though I will not be coaching you on a particular topic, but instead I can discuss with you, okay, what are all the mistakes usually students commit, and this is the result of these videos. So many mistakes, so many mistakes. My God. Okay. Now, if you want to know more about me and my videos that I have been recorded so far, you can visit to my website, which is ratankara.com, and you can go through this. You can get to know all the 97 videos have been uploaded. So you will really have a gamut of information, and this will really be useful, I feel. The structure of the videos that will be here is something like initially the problem would be discussed, and later on we will discuss about the concept which the student has done, the solution. Okay, and why did he commit a mistake? Because he has not understood the concept properly. Where did he make a mistake? And later on, I'll share with the correct solution. Basically, three parts, right? First one is the actual solution. Second part is it tells you about why did he commit the mistake, and last part is understanding the real solution. Okay. Now let us begin with today's video. Now today's video is on center of mass, as I already told you. So the concept is this. Two particles of mass 1 kg each is moving at speeds 5 centimeter per second and 10 centimeter per second. One particle is moving. This is 1 kg, and this is my 1 kg once again. I should have given 2 kgs. Anyway, okay, 1 kg. So one is moving at 5 centimeter per second here, other is moving at 10 centimeter per second here. Find the center of mass velocity. Today, while I was teaching for one of the students, I got this particular, the student got this doubt. He made a mistake like this. Okay, and then the response of the student was center of mass velocity is given by VCM is equal to, this is a usual formula which we tell you, is equal to M1 V1 plus M2 V2 divided by M1 plus M2. So what did the student do? Student just substituted directly the values of masses, values of velocities, and then find it out. See, 1 kg multiplied by V1 plus 1 kg multiplied by 10 V2, okay, divided by 1 plus 1, he got it. Now the question is that when can we apply this equation? Okay, when can we apply this particular equation? Now remember, this V1 and V2 are vectors. VCM is also vector. When I say a vector, you can add two vectors like the normal vectors. For example, if I have one vector which is having 2 units, other vector which is having 3 units, vector A and vector B, then vector A plus B would be equal to 5 units only and only if and only if the vector A is in this direction, Vector B is also in the same direction. Then you can add it. But if suppose if vector A and vector B are having different directions, let us say vector A is moving like this, Okay, and the vector B is moving like this. Can you add these two vectors? You cannot add, right? If you want to add, there are two methods. The first method is take the resultant of these two, vector addition method, right? You take one vector like this, other vector like this, and this would be the resultant vector. This one way. The other way is find out the horizontal in both of these cases. And then what you do, you resolve this into two parts. Okay, along this direction, if this is vector A, get the A cos theta here and A sin theta here. And similarly, here it is, let us say this is alpha, get A cos alpha here, and here it is A sin alpha here. Now you see, you get two vectors, A cos theta and A cos alpha in the same direction. You can add these two vectors, right? You can add these two vectors. And here there are two vectors, A sin theta upwards and A sin alpha downwards. Since they are in a straight line, you can subtract both of them, right? So therefore, this is what you can do. But instead, the student did not understand this because the question was a bit tricky. The trickiness is that it said with the speeds. The moment you say speed, what will the student do? The student will understand, sir, anyway speed is given. I can consider this only as a scalar quantity. But read the next phrase, as shown, which means the angle is also given. Now, when two informations are given, see, usually I can say with velocities. Or if I give you information like this, then you should be very careful, understand the problem, and then resolve it, right? So therefore, this answer is incorrect. And the misconception is student did not read the question appropriately, and he thought that speed and velocity are one and the same. And while you compute this, you should remember that the velocity is also a vector. The center of mass velocity is a vector. And as a result of it, you can add two vectors only when, because you see, it's a weighted average. You can add these two vectors only if and only if the two vectors are moving in the same direction or indicated in the same direction. Now, if it is indicated in different directions, you should not add it like this. Okay. And once again, your resultant concept will not be followed directly here. Okay. You need to work it out like this. And finally, if you want, you can do it. Okay. So how many center of mass velocities do you think you will have? You will have one center of mass velocity along the x-axis, other center of mass velocity on the y-axis. And then if you want, okay, what is the center of mass? Your total center of mass, you can say x velocity is indicated like this. Y velocity could be indicated either like this or like this, whatever it is. And then you take the resultant of these two and find the answer. Okay, I have just given the gist of it. I have not shown you the working. Let us start working. Okay, now let us move on to the correct solution. What could be the correct solution? Right. So therefore, this student response is incorrect. Oh my God, I didn't delete this. Let me delete this so that it doesn't confuse you forever. In all my slides, I have not put this value at all. This particular thing, I have forgotten to remove this. Okay, fine. Okay, friends. Now let us begin. Now what did I say? I said that this is at a different angle. So the component of this 5 centimeter per second along this direction is 5 cos 37. The component of this 5 centimeter along vertical direction upwards is 5 sin 37. Similarly, 10 centimeter per second along this direction is nothing but 10 cos 37. And along this direction, this should be 10 sin 37. Now what I should do? I should add vectors either in the same direction or in the opposite direction. Now how do I do? Now I have one vector in this direction. I have one vector in this direction, which is 5 cos 37. I have another vector which is in this direction, which is 10 cos 37. What is the sum of these two? This should be 5 plus 10, which is 15. 15 cos 37. Now what's the value of cos 37? Which should be 15 into 4 by 5. 5 ones are 5 threes are, which is equal to 12. 3 into 4, 12. What is the unit? What is this now we are doing? This is centimeter per second, right? Centimeter per second. Let me retain it. Then what's the next step? Now let us take, this is for your x-axis. This is for your x-axis. Now let me do it for your y-axis. For y-axis, what happens? You have 5 sin 37, which is pointing upwards. And then you have 10 sin 37, which is pointing downwards. This is my point O. See the length of the vectors also. I am writing it double. Okay, this length is some 2 centimeter, I'm writing this 4 centimeter here. Okay, something like this I'm doing it. So therefore, now when I add, what will this happen? You will get the answer 10 sine 37 minus 5 sine 37, or you will get the answer as minus 5 sine 37, which means the resultant vector here is in this downward direction, right? Now, what is the answer here? It should be minus 5 into 3 by 5. 5 ones are 5 ones are, which should be minus 3 meter per second. Now, what have we got? Let us once again review this. We have got Vxcom, Cm. Vxcm is equal to 12 centimeter per second. Vycm is equal to minus 3 cm per second. You can either retain it, you can just keep it like this, or if you want to find the total center of mass velocity. Okay, guys, he has asked what is the center of mass velocity. Now, what do you need to do? Center of mass velocity being a vector, this is along x-axis, this is along y-axis. This should now be, the magnitude of this should now be equal to square root of 12 square plus minus 3 the whole square. What is the answer for this? This should be square root of 144 plus 9. Now, finally, what is the answer I get? 144 plus 9 should be equal to 144 plus 9 should be 153. Okay. Now, let us find out what is the value for 153. Root of 153, square root of 153 is 12.36. It's 12.369. Maybe I can say it is 12.4 centimeter per second. This is the final answer. I hope you have understood this problem, how to work on this. So, thank you, friends, for watching this video until the end. And if you have any more doubts, you can definitely write back to me. My email ID is over here. gmail.com. Or maybe you can also message me through WhatsApp using this number. Okay, so both are accepted. I can just take up that and pull it over here. And please do like, share, and comment and subscribe to my channel so that it will help me out and I can monetize this channel much more faster. So it's all dependent on your likes and the way how you share with your other students, community will really help me out. Thank you, friends, for watching this video. Bye. See you in the next video.